Hey everyone. So today we're going to talk about displacement, time, and velocity. Um, so this is related to the mechanics portion of physics, and yeah. So let's just get into it, and we'll go over some basic concepts, some basic mathematical representations of it, and kind of like the relationships, and a couple different ways to maybe look at it. Um, so let's get started. So let's just say that we have some kind of car at this point here, and let's draw like an x-axis, and let's say this is at time t equals 0. So at time t equals 0, the car is at position x naught, and let's say the car starts going this way, and let's say like 5 seconds go by, or some time goes by, and now at t1, the car is now at this new position x1. And let's say, for some argument's sakes, that t naught is equal to 0, so at time t equals 0, let's say t1 is equal to 5 seconds, and let's say x naught is equal to x equals 0 on this x-axis, and x1 is equal to 50 meters, and let's make this seconds. So what is the displacement? Displacement is the change of x. So this delta sign is representative of like a change in x. So it's kind of read like a change in x is equal to x1 minus x0. So in this case, it would be 50 minus 0, which is equal to 50 meters. Now this is the displacement of the car, 50 meters. Now the change in t, which is the change in time, is equal to t1 minus t0, which is equal to 5 seconds minus 0 seconds, which equals 5 seconds. So this is the change in time, which is 5 seconds. So this process involved a change in displacement and a change in time. So if we divide displacement by the change in time, which will look like delta x over delta t, we get 50 meters divided by 5 seconds, and 50 divided by 5 is 0 meters per second. And so this quantity here, delta x delta t, is equal to the average velocity. So the average velocity for this process was 10 meters per second. So we have that down right now. Now, velocity and displacement, what's important to note here is that they're vectors and not scalars. So they have an associated direction. So in this case, since the displacement is, we're defining the positive x direction to be this way, to be from left to right. And since the displacement was left to right, which means that the x value is becoming more positive, we know that this vector, this velocity vector, is also going to be positive. Now let's do the opposite. If you had the opposite situation where the car went from 50 meters to 0 meters in 5 seconds, then the velocity would be negative, because the displacement is becoming more negative. So another way to kind of look at these concepts is to look at it graphically, and this is going to help you out when we start talking about instantaneous velocities and things of that nature. If you plot, let's see, if you plot, if you make this t and make this x, and you say that you have some kind of curve that looks like this, and that starts from here, and let's say this point here is x naught, and this point here is x1, and this point here is t0, this point here is t1. You can see that this here, this length here on this graph is delta t, and you can see here that this length here is delta x, so the slope, if you connect this point and this point of this line, the slope of this line here, oh sorry, this is a delta x. The slope of this line here is going to be equal to V average. So that concludes. Oh, and one thing we want to go over real quick is that there's a difference between the velocity and the speed of an object. Velocity is a vector, so it has a direction and magnitude, and the speed is just a scalar, and it's just the magnitude of the velocity, so it has no direction. So we have a v1, let's say that's plus 5 meters per second. We know that if we're talking about like a coordinate system with an x direction, this is defined as positive. We know that there's a velocity is going in this direction at v1, and let's say we have another velocity that's v2, which is minus 6 meters per second. So we know that this other object that's going at v2 is going to be going this way, v2. So the speed of v1, which we're going to call s1, is equal to 5 meters per second, and the speed of v2, called s2, is equal to 6 meters per second. So these are both positive, they have no direction, they're just the magnitude of these velocity vectors. So that's the difference between velocity and speed. So that's it, guys. If you guys like this video and want me to go over more examples, leave them down in the comments below. If you like this video, like the video and subscribe to this channel. And that's it for today.